already introduced, so we can speak by part. So we'll be talking about green development. And it is a thing, at least as a concept in a real estate development, and basically it stands for the development concept which carefully considers social and environmental impacts of the development. And I think it perfectly applies to iOS development, because if you think about social impacts, we're already doing a pretty great job here, because we care about privacy of our users, we care about these users which is not that highly represented, and I think it's time to also think about environmental impacts. And it might sound a bit strange, how does my app can affect the environment? This is crazy. But let's think about it. You have an app. It's kind of small, sorry. And app drains the battery on the device. And then the battery drains, user need to charge the device. So it comes to a charger, and then the device is plugged in, it consumes electricity. And while it consumes electricity, we need to also produce electricity, so it will be everywhere. And here comes the emissions. And you probably heard about these emissions quite a lot, and it's like everywhere now, and all these things about the global warming and the climate change. It's actually the, like you heard about the carbon footprint, and basically this is the, that thing there, CO2, carbon dioxide. This is the reason why everybody talking about it. It's pretty harmless in general, I would say. It's just too much of it. And what happens, this gas, carbon dioxide, it is a greenhouse gas. What it does, it accumulates the heat. And the planet, the whole planet, it becomes warmer and warmer. And so it leads to the global warming. So how does it connect it to the iOS development? So basically, what we can do is to save some energy. If you think about what, how much, so during the combustion of fossil fuels, like oil or fuel, to the atmosphere will be rejected, to produce 1 kilowatt hour of energy will be rejected 800 grams of CO2. It's not that much, but in general, it's just good to know this number. Just remember it for now. Let's look at other numbers so we'll understand what's the problem and what we can do about it. Have you ever thought how much energy do we need to charge an iPhone? It depends, of course, depending on the device, because during the year, since no new devices are introduced, the capacity and volume of the battery is only growing, and this happens through a year, years and years. So, this is iPhone 11 Pro Max is the biggest in terms of volume of the battery, of the capacity of the battery. And if you just imagine, you use it every day, you just drain it fully each day during the year, and you charge it again every day. And then over a year, it will be something about 5.5 kilowatt hours total. And this is like pretty low number if you face it like that. But let's just think about it in scale. And this is a number of iPhones which were in use worldwide in January 2018, this year. 800 million iPhones, okay? You remember the previous numbers? Let's calculate. So you have one iPhone. Let's imagine you have the last one, you're a lucky one. So 5.5 kilowatt hours per year to charge an iPhone, something like 2 euros or maybe 3 euros you will pay per year to charge it. In the amount of CO2 released to the atmosphere during the combustion process or burning fossil fuels during this year to produce this 5.5 kilowatt hours of energy, it will be 4.4 kilograms of CO2 released to the atmosphere. So we have 900 million iPhone devices worldwide in use. So this is the number that will be released to the atmosphere to produce this amount of energy which will be needed to charge all these 900 million iPhones. This is a pretty big number. So if you think about it as in scale, it's already a lot. And what is important, you know, I'm always talking to my friends and we speak about the climate change. I mean, you can't avoid this topic. Everybody would be speaking now about, I don't know, the lack of rice worldwide. We don't have any rice. No rice anymore. Everybody would be speaking about that. But since now everybody is speaking about the climate change, this is like a topic we speak about normally. And they usually say to me, I'm the only one. I don't need, nothing will be changed if I will have my reusable cup or reusable straw. I will change my electricity provider and use the renewable energy. And all of you don't have this excuse. You are not alone. You have responsibilities for your users. So imagine, maybe you have only one user. Maybe you have 100. Maybe you have 1,000,000. And this is something. And if you would not care about the energy consumption of your app, that would lead to the problem. I mean, it's not a big number. The iPhones in general are probably the least consuming devices in your household. So everything else, your laptops, I don't know, microwave, fridges, they consume more. But this already something that you can do, and you have responsibility for the users. So let's see what we can do about it. So first thing, which is good to know, is understand how the electricity is used on the iPhone. What affects the electricity consumption on the phone? So there is no single solution for conserving energy on the device. If you think about it, everything consumes electricity. And the major consumer of energy is CPU. Central processing unit is just, I mean, high periods of CPU, they rapidly drain users' battery. CPU, so like your app uses CPU for almost everything that it does, and it should actually, but it should use it wisely, only necessary through batching, scheduling, and prioritizing. Also, device wake. iOS devices rely on sleep for great battery life. And whenever a device wakes, there is a high overhead cost, as the screen and other resources must be powered up. If you forgot what it is, let's have a look. So this is just a simple graph. So remember, power over time times energy. This is how energy is consumed on the device. So if you think about the overhead, it's all which is red on the graph. And this is actually the cost of the starting hardware, if you think about it. And green, all the things when the app is active. So CPU usage is expensive, if we come back to that. And as more CPU is used, the more power draw occurs. More energy is used, then the device battery drains faster. So other things which affects the battery, networking operations, obviously. It has a high fixed cost on the iOS. Whenever networking occurs, like when you need to, I don't know, Wi-Fi must power up or something. So it always costs a lot of energy. So how we can save it? By batching and reducing transaction, compressing that data, and appropriately handling errors. And then, in that case, your app will make significant contribution to energy conservation. Graphics, animations, video, obviously, every time you have contact updates on the screen, it uses energy to produce those pixels. So just avoid updating the contact, if it's possible, and if in that cases, then the interface doesn't visible to the user. You can imagine you have like, oh, you're traveling home, you're in a taxi and you're really hungry, you want to get your pizza. By the time you're arriving home. So you have this pizza app, like delivery app. So you're coming there and you don't have a good network because you're somewhere in Italy, probably not in your home, you're visiting a conference and you really, really need this pizza because you're hungry and somebody forgot to feed you. Doesn't happen here, but anyways. So, and in that case, you're really aware how does the margarita looks like, or you're aware how does the pepperoni looks like. I don't think there's anybody in this room who doesn't know it. So you don't need the full picture of the pizza. You just probably, you can exclude it and just put the ingredients, and that would be cool. And that will be enough for the user. He can still use the app. Location, coming back to the things that drains the user's battery. So apps make many allocations requests in order to log user physical activity and provide environment-based alerts. So you can reduce accuracy and duration of location activity when it is possible. You actually should whenever it's possible. And probably stop location requests when it's no longer needed. So it will be very helpful as well. Motion. Always request for accelerometer, gyroscope, magnetometer, and other motion data. They just waste energy. When it's not needed, just stop the updates. Bluetooth. High periods of Bluetooth activity can drain the battery of iOS device and Bluetooth device. Whenever possible, batch and buffer Bluetooth activity and reduce pooling for the data. So, this is just general overview how it can be used. It's not only that, but in general, this is important because let's talk about something which will be more specific. Let's talk about the background. What happens in the background? Just remember, life of our app, not running foreground, background, suspended. We're talking about that particular place here, that particular part of work. And there are lots of things happening there. Amazing amount of things that can be proceeding in the background while in the app. Just have a look at all of them, think about them. And if you think about like typical reasons of typical times when energy is wasted in the background, it can be not notifying the system when background activity is complete, playing silently audio, performing location updates, interacting with Bluetooth accessories, download that can be deferred, and else and else and else, just examples. So what can we do? Complete background tasks. Pretty cool. So, imagine you have a messenger app, just for an example. And you need, so user, what user does? He sends a message and he expects that this message will be sent immediately, right now. But he just sent a message and go to another app to check, I don't know, what's the weather like today. Lovely, lovely. So, so what user expects immediate completion of the task. And so what we have to do, we have to protect the completion. So we can give an app additional time in the background before being suspended. So there are different ways how you can deal with background task completion. Let's have a look. So this is an example provided by Apple. So you can guard important tasks while the app is still in the background. So you should, when the task is expired, we should cancel the operation and notify the user about the message. So if message not sent, please resend. User still want it to be sent, and so we should guard it. And if your operation is successfully finished, we should end it and not notify the user about the errors. That's basically how code could look like. Oh, okay. I'll correct it later. So you can also defer the download until the better time. You are somewhere, you just installed the app for your device and you don't want, like imagine it's again a messenger, just a good example. And you don't want all these conversations be downloaded immediately to your phone. All this data, all these pictures sent and everything, you don't want it immediately, you just want to use it right now. So you probably can actually optimize it and protect, like let the app download it at the time when, for example, user will be on a really, really good network and not using phone at least, so it will save some energy as well. So we can, how we can do it, how we can do discretionary background URL session. So we configure a URL, we give some identifier and create a session. Set it to discretionary. Then what we can do, we put some settings here. We can set time at intervals. We should create create request and task, and we can then set time window, which is pretty cool, and set workload size. For example, how much you expect to send, how much you expect to receive. So you can tell the system how much you expect to receive and how much do you expect to send, which is pretty cool. Like all these settings, I think it's very useful for working in the background. Also in background, lots of things new. You can watch the WWDC video, advances in app background execution. WWDC 2018. Pretty cool. Have a look if you can do it. Next thing what we can do, coming from the background to other things. You know, there is really, really cool law which actually applies to everything. If you can measure it, you can manage it. There are lots of tools what we have to make these measurements. So we can monitor energy usage in the debugger. You probably, maybe, so like it's in the debug navigator in Xcode, like you go to show the debug navigator. So this is just a screenshot. And you see, we don't want it to be high. We want to achieve it at a certain point to be like that. This is what we need. There are many things here what you can control. You can have a look at this constant overhead, that this bars over there. You can look for CPU, you can look for location, you can look for background, and work with it. Xcode instruments for optimizations. There are pretty cool new instruments there. So, metric kit, Xcode metrics organizer, Xcode test metrics. This is all fantastically useful for us this year. It's easy to adapt. We can do lots of things, and let's have a look how can we do it. So it's really cool that you can do it when the app is in the field, which is pretty nice for us. So how we can collect metrics. This is just an example again. Now we can do measures on the launch time, which is pretty nice now. This is a new thing what we can do. And also we can adapt metric key to receive metrics. How you can do it? So basically you import metric key. So you choose the place where you want to receive metrics, and it's probably wise to do it in an app delegate because it's an entry part of your app. Then you you use MX Metrics Manager. It is a singleton, and they add a link to our cells, and then they implement the method of a protocol to receive these metrics, and we process metrics. This is how basically it will be done. What else can we do better? There's actually also a nice thing called low data mode, and they can adapt it. Together with iOS 13, Apple announced this new feature. It's intended to use less data in a particular network, such as congested on airplane Wi-Fi network. So it disables basically disables background app refresh and discretionary tasks. So for that particular thing, there's a really good article from Daddy Walls about it. I will leave a link at the end of the presentation so you can have a look. He explains how you can adapt to low data mode perfectly. But in general, suggested techniques for confirming to low data mode will be to reduce image quality, to reduce prefetching, to sync less, and often using locally cached data more heavily. Also, mark background tasks as discretionary, which we already discussed. Disable autoplay, and please do not block user initiated work even through low data mode is on, because they should perfectly be aware what is it, low data mode. And we can do even more. So it's all related to the climate change and everything. And you know, if we do not act right now, global warming is coming soon, and we might see the screen more often. So we can understand device conditions. It's pretty interesting in terms if you have users from all over the world, and you usually test your app in a good conditions. While you're in the office, you have a good network, you have good air conditioning, you're perfectly fine, everything is all right. But imagine you will be somewhere in a desert, probably it will be not that useful, but anyway, it will be somewhere when it's too cold or too hot. I visited my grandmother, actually grandmother of my husband, and it's -30. It's above the polar circle. It's very freezing. You can't really use your phone, and sometimes you can get some warnings that some things is disabled. So how does the heat damage batteries? Let's just think about it. Let's think about the heat. And it's not only bad for, in general, performance and user experience. It's also bad in general for the device. You should probably just avoid being somewhere when it's pretty hot. And we should also avoid global warming, which is important. So let's just discuss what happens to the batteries. Hot temperature causes permanent damage to batteries. That is just like it will happen for really, really a long time. Once you heat it, it's changing completely the structure inside the lithium batteries, which is inside the iPhones. It also, components inside, like voltage indicator, can be affected by the heat as well. So you will never get the right numbers. And all batteries heat up, and then they heat up. Chemical reactions inside will also occur faster. So it can actually be some really, really bad examples. It wouldn't blow up, I think, but it could be something which is not nice. So please, save the battery. Think about it. And let's think about tools for various temperatures. So thermostat conditions. Let's just, for a sec, think about that. So we'll be talking about how to work with thermostat conditions. Let's first to discuss what is them. So they define it as nominal, fair, serious, and critical. Nominal is just normal, no actions is needed. Fair is just then, so Apple suggests that photo analysis pauses at that time. For example, if it's serious, ARKit and FaceTime reduce FPS rate and restore from iCloud is paused, and then the critical ARKit and FaceTime drop FPS rate. This is all needed to be handled just because users have to have an opportunity to make a SOS call, for example. So device will be still working for very, very important things. So what can we do? We can register for processing for thermal state did change notifications. We can use processing for thermal state, which we can use it to make cases to react to thermal state changes. And we can switch off background and then need the functionality when thermal state is elevated. So how we can do it? Let's look for some code. So we create an observer and some function. Let's just react to thermal state change. And now we use the protos info thermal state cases to react to thermal state changes. So we have these different cases. Oh, nominal is all good, serious is something went wrong, and critical is panic. So what you can do, just like how it should look. So probably when all is good, you can just leave it as it is. You don't need to like enable, you don't need to disable face tracking, you don't need to render motion blur. If it's serious, it will be probably like that. You still can have this motion blur. And if it's critical, you should just panic and disable everything because it's really bad. Just call SOS instantly. So let's just sum it up. So you should think about the background. Lots of things that can be done. Apps are different. You have absolutely different applications for them. And it will be absolutely very specific for each of the developer, or for each of the app. You should minimize networking as much as possible and measure as much as possible. Because remember, with great power comes great responsibility. And you have this power, and you have responsibility and accountability for your users, and also a little bit for the future. So you, as an app developer, you have an obligation to make sure your app runs efficiently as possible. If I didn't confuse you with the climate change, go to the settings, have a look at the battery usage, and see this losers list over there. First 3 or 5 apps which consumes your battery most will be deleted by the user, even if you use him a lot. That happened to me, for example, a couple of times. When I used it as a user, I deleted a couple of apps because it consumes my battery in the background, in the foreground. This is the performance, this is important for the user. They will try, nowadays especially, thinking about all of this, they will try to choose the product which respects their battery performance on their devices. So that's all for now. Further links and reading. This is I want to say about it. So first link is just a presentation. Stefan C. Manello, he had a very similar talk about also, it's called Save the Environment with Xcode. And he is a climate activist himself, and he cares a lot about the environment, and he acts right now. So have a look, and also some insights about new features which we have. Also, this is the promised Donny Wall's link about how you can support low data mode in your app. And this is really, really good WWDC 2018 videos, which might be very useful for you, and really cool energy efficiency guide for iOS apps, which is a little bit old, so all the new things you will find in WWDC 2018 videos, which will provide you a good overview of everything. And if you want deep dive, you can go back to this energy efficiency guide. Thank you very much for your attention.